What's up, calculus students? Everybody's favorite lesson slash unit. Stuff that we kind of already know how to do, but it's like different and it's confusing, but we're gonna be okay. Key is you gotta be able to adjust and adapt. Can't just do the same thing every time. You gotta understand what you have. I have the graph of F. You got to understand what the questions are asking you. I'm asking you about the graph of G. Oh, well, G is 2x plus the accumulation of the area under F. Cool. If I wanted G to 2, I would have to do 4 plus the accumulation from 0 to 4, or 0 to 2. If I have G of -3, I would have -6 plus the accumulation of F from 0 to -3. Careful, you're going to go backwards. If I have G prime, I have to take the derivative of this. Well, the derivative of 2x is 2. The derivative of the integral is not the accumulation of f prime. We understand that this could be seen as big F of x minus big F of 0. Cool, this is the whole triangle. I put it up on the board over my shoulder. I don't know if you can see it, but whatever. But the idea that like we could use an antiderivative to find an accumulation, cool. But when I take the derivative of this, I just get regular f. So the derivative of the accumulation function for this situation is just regular f. It's f of x. If you're like, oh, it's f of t, it's like, well, it's not f of t, but don't worry about it. It's just f. Y values. Now, if I take the second derivative, that means second derivative is going to be equal to the derivative of the first derivative. This is the first derivative. I should probably put this right here. And the derivative of 2 plus f would be not 2 plus f prime, but just f prime. And if you guys are not doing this and just copying this down, it's upsetting. You have to do it. You have to, you guys are not making mistakes anymore. You guys are just like going through the motions now, copying stuff down more and more, not actually doing it. All right. This is base 2 out of 4, so this is 4. Base 2 out of -4. Got 4 plus, this is 8. I got to do the opposite. -3 to 0. I'm going, 0 is my starting value. -3 to 0 is 1, 2, 3, 1, 2, 3, 4. So this is going to be 12, 6. Take the opposite, it'll be -6. I'm going backwards. So I have -6 minus 6, which is -12. How many of you got that actually? How many of you actually got that? It's tricky. You have to think about it. -3 to 0 is 6. This would be -6, -12. Slope, I go down 4 over 2, so it's -2. This is f. This is the slope of f. This is f, so that's the y value of f. Now I change it up. Here's another accumulation plus. H is the accumulation from -3 to x squared of f. What is h of 2 and what's h prime of 2? Well, if I found h of 2, that's easy. Squaring 2 gives me 4. Great. Could I find this geometrically? Yes, I can. -3 to 4. Well, I go -3 to 0, 0 to 4, so I got 6 plus 4 minus 4, I get 6. Great. And now we get to h prime of 2. So everybody, woo, woo, woo. Can you get this? Can you get this? Here we go. Well, what is the derivative of this accumulation function with x squared in it? Because of the chain rule, it is f of x squared times 2x minus 0. What? How do you get that? I'm going to show you. Well, another way to write this accumulation function would be big F of x squared minus big F of -3. It's the whole idea of the antiderivative displacement gives me the accumulation of the derivative. Great. Well, if I took the derivative of this, I would have to use an O and an I, and big F would go back to regular F, and x squared would go to 2x. H prime of 2 would be regular F of x squared times 2x, or H prime of x would be regular x squared times 2x, which means, oh, and then like, what's the derivative of f of -3? You might think it's regular f of -3, but not true. This is a number. It's like a value. It's a C value. Its derivative is 0. And that's another thing that's confusing to students. So I need to find f of 4 and then multiply it by 4. F of 4 is -4. Multiply by 4 is like -16. I threw these in. I don't know if they're even going to work, but I want you to be able to adjust and adapt. Now I'm saying J is the accumulation of f prime from -3 to x squared. And it's like, okay, well, it's J of 2. Well, it'd be the accumulation from -3 to 4 of f prime. Do you have f prime? No. Could you graph f prime? Yes. You can see what the slopes are over your intervals. Don't want us to do that because I want us to be like, oh, the accumulation of a derivative, the accumulation of something can be found by looking at the displacement or subtracting our positions. F prime goes to F. F goes to big F. That's the whole idea right here. Or if you can't see it, this is the whole idea of you want to accumulate something, F prime, you can look at F and F. You can find these values. If this is 7 and if this is 2, subtract them and you get this is 5. Because 2 plus 5 is 7. 7 minus 5 is 2. It's like these three things work together. We were used to doing this with P prime or velocity. It's all the same deal. F of 4 is -4. F of -3 is 0. So my displacement is -4. I've decreased 4. And then what is J prime of 2? So I don't even know how this is going to work out. So I'm going to write it down. I don't know. Like I've never done this before. So I'm going to say, well, J of x could be written as regular f of x squared minus regular f of -3. Regular f of -3 is 0. That means J prime is going to equal f's derivative at x squared times 2x minus 0. F of -3 is 0, the derivative is 0. So like it's just a different level down, but now if I want to find J prime of 2, I need f prime of 4 times 4 versus f of 4 times 4. I don't know what f prime of 4 is. I can't do that. F prime of 4, let's just assume that the thing kept going. Let's just assume. The slope of this is -2. I would say the slope is -2 times 4, and I get -8. Again, this is the slope of f. Okay, there's f. And I'm just this is assuming that the graph continues on. All right, now we're back to g. Okay, g is the accumulation of f from 0 to x plus 2x. I want to find the min value of g. Okay, well, to figure out g and its behavior, you look at its derivative. Well, g prime is 2 plus f. We found that. Okay? Now, 2 ways to handle this. Turns out this is not g prime. 2 plus f is g prime. If you'd like to, this is your first option, which I don't like, you could adjust this by adding 2 to all of the values. And this is now your graph of G prime. But notice, like, it's tough to graph things perfectly over this entire interval. It's a little bit confusing. I can't really see. Is it going to be at 3? Is it not going to be at 3? So what I like to do is I like to say, well, G prime equals 2 plus F. When does that equal 0? That's when F equals -2. I'd like to say, let's find when F equals -2. And then when F is below -2, we'll find that 2 plus F is going to be negative. When F is greater than -2, we'll find that 2 plus F is positive. So this is like our new axis. And we can kind of see where this point is, but I'm not exactly sure. So what I want to kind of do is make sure I understand the slope is down 4/2, which means it's down 2/1. And that confirms things that at 3, we have this critical point. So we look at our derivative and we can see that our line is above the y equals -2 until x equals 3. So 3 is the important value. G prime, which is 2 plus F, therefore would be greater than 0 until then, and it would be less than 0 after then. This just provides our sign analysis looking at this new axis. And it would be the same as if you looked at 2 plus G, you would be like, okay, here's the positive values, here's the negative values separating by 3. Cool? But after I've done that sign analysis, I kind of want to get rid of this and go back to just what I was looking at from the start. Okay? Because now I know G is going to increase then decrease, which means I only have 2 candidates. The candidates are actually at -5 and 4. So G has a min at G of -5 or G of -4 or G of 4, because G prime, which equals 2 plus F, is positive. It's always safe to do greater than or equal to 0 from -5 to 3. And then G prime is 2 plus F is negative from 3 to 4. Cool. Now I just got to find G of -5. That'll be -10 plus the accumulation from 0 to -5 of F. So 0 to -5. This is a +6. This is a +2. So it would be -8. And then G of 4 would be 8 plus the accumulation from 0 to 4 of F. This one is going to be the tricky one because, no, it's 3. Not oh, yeah, because of the min. This is not going to be that tricky because we already did it, kind of. This is 3. No, this is 4. One, 2, 4, and this is -4. Cool. So we get 8. Yeah, this makes a lot of sense, actually. 8 plus 0, which is just 8. You're like, wow, that was a candidate? Yeah. We actually increase a lot. The idea of the 2x plus the accumulation will be a lot of increasing and then just a little bit of decreasing. So our start is our min. Four x. Ooh. Gave this to you for a reason. All right, I got 16 plus the accumulation from -2 to 4 of G. -2 is here. All right, so I got 1, 2, 3, 4, 5, 6, 7, 8. I got this is 8. This is a 2 by 2, which is a 2. This is a 2. This is a -2. And then this is 1, 2, 3, 4 by 1, 2, 3, 4. So this is 8, negative 8. And if I want to go to the left, I'll say this is a positive 2 by 6. So this is 6. All right, so I have 16 plus negative 2 to 4. Oh, jerk. Why did I do that? It's cool. All right, so then anyways, I got to stop it at that, which means this is negative 4, and this is another negative 2. All right, not bad. So I start with 16. I got 8, 9, 10, 11, 12. And then I have a negative 2, 4, 8. So 16 plus 12 minus 8, I get 20. F of 2, 8 plus the integral from negative 2 to 2 of g. Okay, so I got 8 plus a 10 plus a 2. So 8 plus a 12. And then since I'm going to 2, I'm going to add a 2 and then subtract a 2. So 8. I got this 8. I got this 8, this 2, this 2. So 10, 12. So there's that 12. And then, cool. Which means I don't want another 2. So it's really 8 plus 10, which is 18. Yep. Okay, the derivative of f is 4 plus g. This is the graph of g. Don't change your letters. Just adjust and adapt to what you have. All right. 4 plus g is f prime. If I'm wanting to look at when this is equal to 0, that means I'm looking at when g equals negative 4. 4 plus g of 6 is what I'm trying to find. G of 6 is 0. This is the graph of g. G of 6 is 0, so I get 4. 4 plus g of 4. G of 4 is negative 2, so it's 4 plus negative 2, just 2. We'll come back to this later. We're not worrying about it yet, but I want to put down a g equal to negative 4. Ooh, that's going to be interesting. That means we're going to be increasing the entire time. 1 is not a candidate. But throwing out curveballs at you, I'm going to put 3x in here. Okay, well, p of x would equal big G, super G at 3x minus super G at 4. Okay, that doesn't help me, except it helps me find my derivative. This is a number, the derivative is 0. I'll show you in a second. And then this derivative, using the chain rule, is the derivative of big G times the derivative of 3x. Big G goes to regular G. You could say it's big G prime, but I'm going to say it's regular G of 3x times 3. Cool. So P prime of 2 is G of 6 times 3. G of 6 is 0 times 3 is 0. So it happens to be 0. Make sure you get it the right reason. Then, what if I ask you what P of x is? Well, P of 2, it's going to be easier to just plug in 2 and get the accumulation from 4 to 6. Going from 4 to 6, it's just going to be this area here, which is going to be negative 2. Great. Oh, curveball again. I have a G prime here. I have a 3x here. Cool. Well, that means n of x equals G of 3x minus G of 4. Or if I wanted to find n of 1, it would be G of 3, or it'd be the integral from 4 to 3 of G prime, which is G of 3 minus G of 4. Now, it's the opposite of G of 4 minus G of 3, but like whatever, here, since we're going backwards, we are going to kind of take this and subtract that to figure out how much I decrease. There's options to you here. You could say this is the opposite of 3 to 4 of G prime. Okay, now that means I need G of 3 and G of 4. G of 3 is -3. G of 4 is -2. So the displacement is 1. But since I go G of 3 minus G of 4, I'm going to get a negative value. It's like, oof. From 3 to 4, I increase 1. From 4 to 3, I'm going to decrease 1. Or you could just like do the math. This is -3 minus -2, and you get -1. Now, what about the derivative? Okay, well, since this is n prime, using the chain rule, this is -2, is g prime of 3x times 3, and then g of 4's derivative is 0, because it's -2, and -2's derivative is 0, which means n prime of 1 equals g prime of 3 times 3. G prime of 3 is the slope. Happens to be 1 times 3 is 3. Max F. All right, F. Boom. Max F. I got to look at 4 plus F. Add 4 to everything. You're all the way up here. You're all the way up here. You go all the way up there. And we go all the way up here. There's F prime. This is now F prime, this graph. Notice it's positive everywhere. Or you could say, let's analyze 4 plus F and figure out when that equals 0, because that's G prime, which I'll do in a second. You'd be like, okay, that's when F is equal to -4. How do I do that? I subtract 4. I can totally tell who doesn't do their homework because they like make the line at 4, but the line should be at -4. Cool. Well, you could see that your G prime values, which are 4 plus F, all of these values are bigger than -4, which means 4 plus those values would give us positives. We do have a 0 at 2. 2 would be a critical point, but we have positives after that, which means G is increasing the entire time. Yes, it flattens out here, but it's increasing. What's the max? Well, if your function continues to increase, G of 7 must be the max, because G prime, which equals 4 plus F, is positive or equal to 0 from 0 to 7. Okay, so I don't know why I said 0 to 7. I meant -4 to 6. Anyways, it should be G of 6. What's G of 6? F of 6. Oh my gosh, did I do... It's 4 plus G. I just made a mistake. I'm literally told you guys, like, don't mix it up. Oof. All right. F is 4 plus G. F prime is 4 plus G. Cool. F of 6 must be the max. What is the value of F of 6? F of 6 equals 4 times 6, which is 24, plus -2 to 6 of G. So not only is like that helping increase, but everything else is helping things increase. So what did I say this was? This is 8, this is 2, this was 2, this was -2, this was a 1, 2, 3, 4 by 4, so this is -8. So these cancel. So these cancel. These cancel. It really is just 2. That's 26. All right, going right to the funky stuff. Here we got n, x plus, integral from 0 to x of m. Okay. Then I switch it up to w, and I say w is the integral from 0 to 2x of m. What's w prime of negative 2? Okay, well, w would be super m. Oh, that's ugly. At 2x minus super m at 0. That doesn't help me find w values, but it does help me understand w's derivative, which will go back to regular m of 2x. What starts in the parentheses stays in the parentheses times 2. And this is just a number. It's a constant, which we will subtract from. And when we take the derivative, become a 0, which means w prime of negative 2 is m of negative 4 times 2. This is the graph of m. M of negative 4 is negative 1 times 2 is negative 2. Boom, look at that. I'm glad I changed it up on you. Ooh. L of negative 2 would be the integral from 0 to negative 4 of m prime. What is the integral of m prime? Well, this is m, not m prime, so maybe I should write it as m of negative 4 minus m of 0. You can also just make sure you go from left to right and go m of 0 minus m of negative 4. But it just works out if you say this is negative 1 and this is 3, and you displace 4 to the left. If you go from 0 to negative 4, I'm decreasing by 4. If you're talking about the function values. You could have also said L is m of 2x minus m of 0. Okay, well, m of 0 is 1, 2, 3. So you could say it's m of 2x minus 3. Cool. Which means if you want to find L of negative 2, it's m of negative 4 minus 3. It might be easier to have those numbers in there. But where this helps us is we can look at the derivative of L. Well, it would be the derivative of m of 2x minus 3. Use the chain rule. You get m prime of 2x times 2 minus 0, because the derivative of 3 is 0. Which means L prime of negative 2 is m prime of negative 4 times 2. Assuming that this is like that, we could say that's 0. The slope of m is 0. Now look at that concavity. It's m prime, which is the slope of m. We can assume it's 0. It's an endpoint. We don't like to discuss derivatives at endpoints, but whatever. All right, now we can talk about the min value of n. Here's n. Here's n up here. Got so many different letters, you got to keep track of it. Well, n prime equals 1 plus m, right? The derivative of the integral with nothing crazy. This would be super m at x minus super m at 0. If I took the derivative, I'd go back to regular m minus 0, and the derivative of x is 1, which means I want to look at when m equals negative 1, and I want to plop down a point at negative 1. Now, it's a little tricky. Don't guess. 1, 2, 3, 4, 5, 6. 1, 2, 3. So it's down 6 over 3. So it is a slope of negative 2, but I go down 2 over 1. Okay, down 2 over 1. It does work out that it's at a nice whole number. It won't always be a nice whole number. So n prime, which gives you 1 plus m. 1 plus m will be, since m is above negative 1, 1 plus m, if you take these values and add them, will be positive until 2 and then negative after 2. Why do I keep giving you endpoints? Sucks. 2 is a very important value. That means n is increasing then decreasing, which means we're going to have a min at either n of -4 or n of 3, because n prime is positive from -4 to 2, and n prime is negative from 2 to 3. Cool. I'm assuming we're going to start at our min and we're going to increase a bunch and decrease a little bit. So let's find n of -4. It's -4 plus the integral from 0 to -4 of m. Erase this line, forget about it. You could think about accumulating things, but it's going to be complicated. So we could just do this. This is a quarter circle. So this is 1/4 of a pi times 3 squared. So this is 9/4 pi. This is a quarter circle. So this is pi over 4. It's negative. So I'm going to have -4 going backwards. So I'm going to subtract this and add this, which means I will be subtracting 8/4 pi, which is subtracting 2 pi. So I start from a little value. I decrease pi over 4. Well, I accumulate this negative pi over. Okay. Sometimes it's really tricky. -4 to 0 would be 2 pi. I want to subtract 2 pi. Okay, we're good. And then we got n of 3, which will be 3 plus the integral from 0 to 3 of m. 0 to 3. Ooh, 1, 2. Oh, that's fine. That's the endpoint. I don't have to worry about 2, which will be a weird mini value. I should have asked you for the max, but whatever. You can figure it out. This is 1.5. This is 1, 2, 3, and this is 1.5. Down 2 over 1, down 1 over 1/2. So this is 3 halves and 3. So this is 9 halves divided by 2, which is 9/4. Woo! And this is also 9/4. This is -9/4. All right, that works out. So this is 3, which means this is the min. Well, R could also be written as big super W of -x squared minus big super W of 1, which means R of 2, if I wanted to find it, could be used. But it means R prime could be found and understood. R prime, which is the derivative of this, using the chain rule, O and I it, super W would go back to regular W. What starts in the parentheses stays in the parentheses. And then we have the derivative of what's in there. And then the derivative of super W of 1. W of 1 is a number, so its derivative is 0. So R prime of 2 is regular W of -4 times -4. Cool. 1, -4. This is the graph of W. So W of -4 is 1. Whew, who knows if this works out? Okay, so P is regular W of -x squared minus regular W of 1. Take the antiderivative, displacement of the antiderivative, displacement of the position, accumulates your derivative. That's the idea. Okay, well, that means P of 2, let's throw that in there. That means P of 2 would equal regular W of -4 minus regular W of 1. Regular W of -4 is 1. Regular W of 1 is 0. So this answer is 1. Or what's the displacement of W from 1 to -4? We increase 1. What about P prime? Well, the derivative of this would be W prime of -x squared times -2x, which means P prime of 2 is W prime of -4 times -4. That's the slope. Let's assume that the line continues. We rise 3, run 2. The slope is 3/2. Rise 2, we run 2. Never mind, the slope is 1. W prime of -4, we're going to say, is continuing on the slope, which is 1, so that means this is -4. Great. Max value M. All right, I got to look at M prime. What does M prime happen to equal? Let's come up here. M prime, all right, there it is -x plus the integral. So M prime is -1 plus W. Cool. I can take W and subtract 1, and everything comes down 1. Which means, like, that's the important value, whatever that happens to be. Or I can say I'm trying to figure out when this equals 0, and that's when W equals 1. Create a new axis, and bingo, bango, right there. You can also see right here's what I'm trying to find. Now, what is that value? Well, I go down 1, 2, 3 over 1. So if I go down 2, I'm probably going to go over 2/3. So this is going to be -4/3, or -1 1/3. How the hell do I get that? I don't know. You just think about it. If the slope is down 3 over 1, divide the top and bottom by 3, you get down 1 over 1/3. So I go down 1 over 1/3, down 1 over 1/3. And that's how I get to a y coordinate of 1, starting with -2, which is -6/3, go over 1/3 twice. Woo! That's my max, too. This is the best one. What a great question to end with. And how many of you are actually trying here? Maybe 4. Probably 4, more than 4. I always don't think it. You guys try it. Maybe this stuff is just tough. But, like, come in if it's tough. I'm not going to be so gracious on grades. You guys are slipping. The derivative is positive because these values are above 1. If these values are above 1, then -1 plus those values are going to be positive until -4/3, and then they're negative because the values are negative after that. It's the best question yet because the answer is right there. Max at M of -4/3 because M prime is positive from -4 to -4/3. And M prime is negative from -4/3 to 3. What's the value? Here we go. M of -4/3 equals +4/3 plus the integral from -1 to -4/3 of W. Okay. From -1 to -4/3, I have a base of 1/3 and a height of 1, which means I have a 1/6. I'm going opposite, so I'd be subtracting a 1/6. Okay, so positive 4/3, going backwards. This is positive a sixth, but I would be subtracting a sixth. That's 8/6 minus 1/6, which is 7/6. Find any other value of m. Plug in any other value for m. You will get a value that's less than that, I guarantee. Okay? And now we'll finish off with a free response type question. It's not all free response. I'd probably give you more than this. But let's see where we go. All right, I got F, I got a G, and I got an H, and I said this is the graph of G. Great. Find f of 0, f of 5, h of 6, h prime of 6. Okay, f of 0 would be the integral from 4 to 0 of G. So 4 to 0 is the opposite of 0 to 4. This is a half of a pi 2 squared. So this is 2 pi, but it's underneath the x-axis, so that's negative 2 pi. But when I flip it, it becomes positive 2 pi. So I start at 2 pi. I decrease 2 pi to get to the value at 4, which is 0. Cool, makes sense. What's f of 5? F5, the integral from 4 to 5. All right, well, that's this. It is just a half. Cool. What's h of 6? Integral from 4 to 6 of g prime. Well, I don't have g prime of g. So probably the way to do this one is to look at the antiderivative, because I have it. Now I could have done that here. I could say f is also equal to super g of x minus super g of 4. Maybe that helps me understand that f prime equals g. Doesn't really help me find values, but here h is equal to super g. Oh, wait, no, not super g, regular g of x minus regular g of 4. So g of 6 is 2, g of 4 is 0, so your answer is 2. H prime would just be g prime. G prime of 6 does not exist, it's undefined. H double prime would be g double prime of 2. Well, g double prime, I have the graph of g. G is concave up at 2, which means g double prime is positive. H double prime is positive because g double prime is positive. G double prime is positive because g is concave up. Cool. Points of inflection for F. Where's F? Here's F. Points of inflection for F when F double prime changes sign, when F prime changes direction, when F changes concavity. Well, F prime equals G, write that down somewhere. F prime equaling G, write down that F double prime is G prime. You could say X equals 2 and 6 because F double prime, which equals G prime, changes sign. Or you could say because F prime, which equals G, changes direction. Let h be the function defined by h of x equals f of x minus s. On which intervals, if any, is h decreasing? Well, h will decrease when h prime, which is equal to f prime minus 1, when that's negative. Wait, f prime is equal to g. I remember this was on a free response question. It's a great question. Well, f prime is equal to g. So I wonder when g minus 1 is negative. Oh, well, that's going to be when g is less than 1, adding 1, adding 1. Or let's look at when g equals 1. This is the graph of g. Let's look at when g equals 1. Set my new axis up. Bam, right there. 5. Because h prime, which equals g minus 1, is negative until 5 and then positive after that, which means h is decreasing. So you'd say from 0 to 5. And what's your justification? It's because h prime is less than 0. As long as you have like h prime equaling g minus 1 or f prime minus 1, they'll give you that. What a great question. Were you able to handle that question? Or were you like, I have no idea what I'm doing? You have to adjust and adapt. You got to just be like, okay, what do I have to do? What do I have to do? Okay, I'm looking for when h is decreasing. That means I need h prime. You should have start with that. And you're like, well, what's that equal to? Well, it's f prime minus 1. And then I'm like, well, I don't know what f prime is. And then I look up here and I was like, oh, yeah, f is equal to the accumulation of g. F prime equals g. So it's g minus 1, which means I need to figure out when g equals 1. And boom, I got that. And I see my new axis and I get my answer. This is like the perfect free response question, to be honest. So 0 to 5, because h prime, which equals g minus 1, is negative. Was the absolute minimum value? I mean, we could find it. It's h of 5. H of 5 is the min, again, because h prime is negative from 0 to 5. And then h prime is positive from 5 to 7. So we know h decreases and increases. You want me to find the value? Fine. Fine. I'll find h of 5. Well, h of 5 is this. H of 5 is f of 5 minus 5. What's f of 5? Oh, wait. F of 5 is the accumulation from 4 to 5 of g. Should have asked more questions like this. The accumulation of 4 to 5 of g is something I found already. It was a half. So I have a half minus 5, which is negative 4.5. Here's my justification. This is my min. Because of this, that's my justification. If my derivative is negative from 0 to 5, then positive from 5 to 7. That's the only location of that's the only min possibility. Here's the value. We know it's the absolute min. Practice problems. Tuesday, test Thursday. Peace.